Hello, welcome to Maths with EJD. I continue with the videos on scientific computing with Python today, and this is the 10th one. I'll be talking about NumPy still. So, of course, I like to start from this screen so I can always explain to especially first timers how to navigate your way down to the Jupyter Notebook, especially if you have installed it. If you have not installed Jupyter Notebook, you can check the first video in this series, and I have a whole the process of installing it using Anaconda. Okay, but if you have installed, each time you need to open it, you can proceed like this. First of all, because I'm on Zoom, of course, I share my screen first so that anything I do, anywhere else I go, you can see. Then after this, now I go to my search button because I always use Jupyter Notebook. It's always there. If it's not there, you can search for it. Just type JU, and in the process of typing, you would already see Jupyter Notebook Anaconda 3. Then you click on that. It brings up this command line kind of thing, this terminal. Don't close it because it is the brain behind whatever else you'll be doing. So as this is on, then of course something like a web page opens, which as you can see, and then so you have all your folders here. So you navigate to where you can find what you're working on. So mine is on the desktop, and that's the scientific computing with Python. And today I am talking about indexing and slicing NumPy arrays, indexing and slicing NumPy arrays. Now, there you go. So let's go into the issue. All right, so we're talking about indexing and slicing NumPy arrays. Of course, don't forget also, I have also made the notes available. So I mean, even before you start going too far, you could just go check the description box and download all the notes. This is the 10 video, so I have all the 10 lessons. If you can access that through the link, it leads you to the Google Drive. So you can download the notes and then follow as I do it, so it can be hands-on. And of course, if you have not subscribed, please hit the subscribe button, and of course hit the notification bell. So each time I release a new video, you can always have access to it. And of course, please comment, like, and share because I know this will be useful for a whole lot of people. Then, of course, in your comments, it may be maybe you want to request to learn a particular aspect of Python which I've not dealt with, or I also get to teach maths, right? Or you have a topic in maths you like me to talk about. So let's do that. All right. So indexing and slicing NumPy arrays. So as you can see there, indexing and slicing in NumPy arrays are fundamental operations for accessing, manipulating, and extracting data efficiently. Sometimes you can have a whole, you can have some kinds of data, and you don't need the whole data. You just need to extract some part of it for what you want to do. That is what this whole thing is about. So NumPy offers powerful indexing and slicing capabilities, enabling users to work with arrays in various dimensions and shapes. And of course, let's talk about indexing in general terms. So indexing is more like you're giving the coordinates of some data, right? It's more uh for GPS, right? You need the longitude and latitude of a location that you're interested in. So for indexing, right, you have the data, so you need to pin it down. In Microsoft Excel, that'll be like you want the index in Excel will be something like the cell, which you can know by the row number and the column alphabet. So when you say cell A1, so that A1 is the index. That means that cell belongs to row, it belongs to column A and row 1, something like that. But here, let's see how we do this. Indexing in NumPy arrays is similar to indexing in Python lists, but it extends to multiple dimensions. Now, when we talked about Python variable data structures in Python, we talked about lists, and we told you that since lists is ordered, you can actually index it, you can reference things, and not forgetting that counting in Python starts from 0. Okay, so you can access individual elements of an array using square brackets and providing the index or indices for each dimension, as you're going to see shortly. Okay, so look at okay, let me turn on the line number so I can easily reference using line numbers. So of course we are dealing with NumPy, so it means you have to import NumPy. Don't forget we had in the first video on that number. That should be like video 6 or 7. I'm not sure now. So we had to install it. So since you have installed it, each time you want to use it, you have to import it. Okay. So import NumPy as NP, and then in line 3 now you are making an array out of a Python list. I mean, we have done this a couple of times. So except that today we are going deeper into this whole slicing and indexing thing. So you're making a Python list into a NumPy array. That's what is happening here. So if you want to reference the first element, that will be ARR. The variable name is ARR. So you use ARR. The square brackets we're talking about here is what you have now. ARR 0, and that means the first element because counting starts from 0. Okay, so if you run this, that shows you 1. So if I copy this out now and I say I'm interested in ARR, say I'm interested in ARR, say ARR 3, that's 0, 1, 2, 3. That'll be the number 4, like that. Or better still, let me say I want to change this to A, B, C, D, and E. So ARR 3 now is simply going to be D. Oh, okay, because it's numbers now, I have to put it in quotation. Yeah, that because it's like string. So that's something right there to pay attention to. Anytime you're using a string, it shows you are working with a string is the quotation. All right, and it shows in red like that. So here we're expecting to have D. Okay. So for the next one, you can also do multidimensional stuff. For multidimensional arrays, you provide indices separated by commas, right? For instance, okay, let me print the normal stuff, the normal array, so you can see what's happening. And so the referencing can be easily done. So you say here, I print array 2D so you can actually see the actual array before we reference anything. So now here, you have, if like we already said, if you want to make a two-dimensional array, so it means you need a list of lists. This, you can see this is a list of lists. So the first list will be the first row, which is row 0, and the second list will be the second row, which is actually row 1 in Python terms. Okay, so if you run this now, so this is print array D. So line 3 is what is giving you this. So you have row 1, row 2. So 1, 2, 3, 4, 5, 6. This is row 0, row 1. And then if you want to print 1, comma 2, that means you are referencing the element in row 1, column 2. So this is row 0, row 1. So this is row 1. Column 2, that's column 0, column 1, column 2. And that falls on 6. So that is why you have 6 here as your result, right? So let's do this. Okay, well, I don't even have to copy the whole thing. Yeah, let's say I now have another cell here, and then I want, maybe let's do 1 1 this time around. Let's do 1 1. So 1 1 would mean row 1, column 1. This is row 0, row 1, column 0, column 1. So that's going to be 5. Okay, that sounds boring. Let's do 0 1. Let's do 0 1. Okay, so row 0, column 1. That's going to be 2 in this case. So we expect the result here is going to be 2. So that's 2. Okay, row 0, column 1. All right, so we go to slicing, having been since we are done with indexing. So talking about slicing now, slicing is you extracting, for indexing, you are getting the address, you are calling something using its address. But for slicing, you are cutting a part out. Just like you have a whole cake and you just slice a portion out. That's what slicing is. So you have the whole data and you want to extract a portion of it, not just mere referencing, like what indexing does. So slicing allows you to extract a portion of an array by specifying a range of indices. So you use indices as address to slice things out too, right? So it follows the syntax start, stop, and step. So you start from somewhere, you stop somewhere. Interestingly, where you stop in Python is actually, you don't actually stop where it says to stop. You stop a step short of the stop point. And of course, the step is how many gaps should you have between the start and the stop. So where start is the index, start is the index where the slice begins. Stop is the index where the slice ends. and it is exclusive, meaning that where if I say it's going to end at 10, it means you are going to end at 9. And the step is the step size, like how many steps. You will understand this as we move. So here we have a Python list made into a NumPy array, 1, 2, 3, 4, 5 as usual. Then you're printing array 1 to 4. That means this is 0, this is 1. So you're starting from 2. And since 4 is exclusive, it means you're starting from 2. I mean, yeah, from 1, right? That's 0, 1. You're starting from 1 and you're going to 3. That's 1, 2, 3. All right? Because 4 will not be, you won't reach 4. So you don't reach the top like that. So if you run this now, this is what you get. So you have 2, 3, 4. Now, I like to do different dimensions of this so you can actually get the idea. For instance, if I create a new cell and then I bring this here, and here I just say, there's nothing in the beginning. I just have that place blank, but then it's going up to 4. That means start from the beginning and go to step 3. Or if I say from the beginning, and probably I put, okay, I mean, 4 is the last stage, right? So here, so that means 0, 1, 2, 3. So to me, that's 0 to 3. That is 1, 2, 3, 4. So now 1 is included here. So if you run this, see what you get. So we can also create another cell. Okay, if you create another cell now, I come here and I'll remove, and I'll say from 1 upwards, right? So here I'm not specifying anything. So it means it will go from this point 1 and go all the way. So and at point 1 you have 2. So you are going to have 2, 3, 4, and 5. That's what that is about, 2, 3, 4, 5. Okay, so that works. That works. Okay, so then you can also do it for multidimensional stuff. So you have a 3 by 3 matrix. Okay, let me print this again. Let me print the original thing so we can see how the transformation goes. So we want to print array 2D. You want to print this, and then of course let's have a blank print so you can see whatever it is you are doing. So of course you can see this is a 3 by 3 thing, and then here we need everything. Okay, we need everything from the beginning to 1, because if you don't get to 1, so everything from 0 so you just need 0, 1 here. So that is, you need row 0 and row 1, and there you're also cutting out from column 1 to 4, from column 1 to 2 actually, because it's a 3 by 3 thing. So let me run it so the explanation can be easier. So you can see this is, so everything up to row 1, because you don't get to 2, right? So it means you have here, this is row 0, this is row 1. So it means you're going to extract whatever you need to extract from here. So the next thing, which columns do you need? So you need column 0, column 1. And then you need row 0, row 1. But for columns, you need column 1 to the end, right? And this is column 1. All right, you need these 2 rows, and then you now need column 1 to the end. So this is column 0, column 1, column 2. So 0 is not there, so it starts from 1. So you're working with these 2. So this is column 1, column 2, and that is why you have 2, 3, 5, 6 right here, right? So let's take that. Let's do another one. Let's say now you need say let's say you now need from maybe 0 to let me say from 0 to 3. No, this doesn't go as far as 3. Maybe from 0 to 2. And then this is like from 1 to 2 now. So that means, first of all, for the rows, right? You need row 1, row 2, right? You need row 1, row 2. And then you need column 0, 1. That's 4, 5, 7, 8. This will be 4, 5, 7, 8. 4, 5, 7, and 8. That means row. So okay, you don't go all the way, Okay, let me do row 0 to row 0 2. Yeah. So that's 0, 1, 0, 1. So that's uh row 0, row 1, because you don't get to 2. Then column 0, column 1. That's 1, 2, 4, 5. Sorry. 1, 2, 4, 5. 1, 2, 1, 2, 4, 5. I believe. 1, 2, 4, and 5. So if you run that, let's see what we get. Yeah, 1, 2, 4, 5. Because that's row 0 and row 1, column 0 and column 1. That's 1, 2, 4, 5, like that. Okay, so that takes us to Boolean indexing. Boolean indexing is all about the idea of true or false. So if something evaluates to be true, those are the results you get. So here, Boolean indexing allows you to select elements from an array based on Boolean condition. Boolean condition. So you have the normal array we've been dealing with, Python list becoming NumPy array, and then you need to, from this array now, you need everything in that array that is greater than 3. We've done that kind of thing in a previous video, except that we are going deeper now. So anything greater than 3, so that's 4, 5, that goes. And then if you go two-dimensional, that's also possible. So it means in the whole dimension, okay, again, as I've always done, let's print the normal array underscore 2D, ARR underscore 2D. And then, of course, let me print something blank to space things out. Okay. And then in the whole array 2D, you are looking for every element greater than 3. So that means if you do this, you have 1, 2, 3, 4, 5, 6. So anything greater than 3 here, that's 4, 5, 6, 7, 8, 9. So to just list it out this way. Okay. That's the idea of Boolean indexing. So what if I bring this out now and I say something like, let's say this. Maybe we want something to be between a particular range. Maybe I need array 3. Okay, or let me say, what can I do? Okay, let me even change. Okay, maybe I should bring the whole thing, right? Let me bring the whole thing and do what I need to do. So let's say you have 1, 2, 3, 4, 3, 6, 4, 3, 6, and or better still, let me say 4, 2, 6, and 7, and 2, 8, 9, so to speak. And then I just need everything that is 2 here. I need all the number 2, all the values 2. So invalid syntax. Invalid syntax. Okay. Okay, let's do less than or equal to 2 then. Less than or equal to 2. Less than or equal to 2. So, to show us everything that is less than or equal to 2. So we have 1, 2, 2, 2. So because there are 2 threes like that, So that's about Boolean indexing. So we go to integer array indexing. So integer array indexing allows you to construct arrays using data from another array. So you have an array and you now use that to call things from the original thing you have. So this can be particularly useful when you want to reorder or select specific elements from an array. For instance, you have your normal NumPy array created from a Python list, and then you now create an array of indices again, 0, 1, 2, 0, 1, 3. So if you now say print array indices, so it means you are printing index 0, which is 1, index 1, which is 2, and index 3, which is 3. So, index 3, which is 4, actually. So because this is 0, 1, 2, 0, 1, 2, 3. So 0 is 1, 1 is 2, then 3 is actually 4. That's why the result here is 1, 2, 4. So it's like you are specifying the actual things you want. Now, this makes more sense when the thing is really long. For instance, if I create a new cell, I do this, I now create a new cell. So I have, in fact, let me even say NumPy, and let me do a range now, a range, and then I have, say, a range. So I now have 0 to, maybe I have 1 to 10. Of course, that's a common one. So that's 1 to 9, basically. Then I now need, one. So since I have that, so let's say I now need 0, 3, 0, 3, 7. That'll be the first. In fact, let's even print that so we can see. So if you print the normal print, the T is missing, print the normal ARR, then we have the index, right? So just print blank so we can have some space. So now I now want to print the array with the indices, right? Print the array with the indices. So it means that from here, print the first element, the fourth element, and the eighth element. All right. So that's the first element, of course, is 1. The fourth element is actually 4. And the eighth element is 8, So that's just 1, 4, 8, as you can see, like that. So you can actually do something like this. Okay, so let's talk about advanced indexing. NumPy supports advanced indexing techniques, allowing for more flexible and complex selection of elements from arrays. Advanced indexing provides more flexibility compared to basic slicing and can be particularly useful when dealing with non-contiguous or irregular patterns of data selection. So advanced indexing can be done using integer arrays or Boolean arrays. So again, here you have a you have a 3-row, 2-column matrix, 3 by 2 matrix. And then here you create the number of rows 0, 1, 2, and you create columns 0, 1, 0. So, and you want to pair them, you want to specify like, okay, row 0, column 0, and that is like row 0, column 0. This is row 0, and this is column 0. So that's going to be 1. Then the next one, row 1, column 1. So this is row 0, row 1, then column 1, that's 4. That's why you have 4 here. And lastly, you have row 2, that's 5, 6, that's 0, 1, 2. This is the second row. And then column 0, which is 5. That's why this is going to be 1, 4, 5, like that. So it's like, so you take pairs of this, like that. This gives you a bit more power, so you can go specifically to where you want. Then, of course, we can do the Boolean thing. Now, this is a bit tricky. In this case, I like to even print. So let's print the array itself so we can easily talk about it. So let's print the array, and then let's even print. Okay, let me create a blank print for space, and then so let's now print again the Boolean array, Boolean ARR. Okay, because this can be a bit tricky. So now you want to print ARR Boolean array. So anywhere the Boolean array is true, it will print the corresponding element here. And if I run it, I think it will be easier to understand. So here, this is row 1, row 2. I mean, row 0, 1, 2, row 0, 1, 2. Anywhere that okay, I think I also need to print another blank one here. Print blank, so we can see that separated clearly. Okay, so now this is false, true, true, false, true, true. So false, true. So true here, you have 2. True, false. True here is 3, so 3 comes here. Then true, true, that's 5, 6. That's why the result here is 3, 3, 2, 3, 5, 6. So wherever the Boolean array is actually true, the element to be, whatever element that corresponds with that in the original array is going to be printed out. So that's the Boolean array style. All right. So anything that is true is going to be printed. Very important. So that takes us to slicing steps. Slicing steps. You can specify a step size when slicing NumPy arrays, allowing you to skip elements. So sometimes maybe you just want to you just want to you have steps now. Maybe it's more regular. So now maybe you want to print every second element after the first one, then like this. So you use double column sign for that. So you have an array again from 1 to 9, and then you want to print every other second number after the first one. So the first one is guaranteed. So print array double colon 2. That means print the first one, then 1, 2, print, 1, 2, print, 1, 2, print, 1, 2, print, like that. And there you have it. Okay, for you to get a better sense of this, let me do 3 steps, right? Let me say you go 3 steps. So here, it means you print the first element 3, right? Print the first element 1, print this one, and then after that, 1, 2, 3. So it means the next thing is going to be 4. After 4, the next thing is 1, 2, 3. That is 7. Okay. And after 7, 1, 2. So it means you're just going to have 1, 4, and 7 here. All right. You're just going to have 1, 4, and 7. Okay. Let me even take it to 4, let me take it to 4. In fact, here we don't need the first row because it's already up there. As far as it is run, you can always refer to it. So let's take another one. Let's go 4 steps. So I'm going 4 steps now. So don't forget the first element to be printed. So 1 is going to be printed. And then, of course, this will be gone. So we start again. So after 1, 1, 2, 3, 4. That's 5. After 5, 1, 2, 3, 4. That is 9. And that's what you're going to get. All right. In fact, let me take it to 5 to really drive the point home. So for clarity. So if you come here now and you do double column 5, and then it will print 1, all right, and you count 5. 1, 2, it will print 1, 1, 2, 3, 4, 5. That is 6. After 6, you just have 1, 2, 3. So yeah, all you're going to have there is 1 and 6, like that. So that makes a lot of sense. You can actually do it in the reverse, like you're coming from the back now. So if you do -2 from the back, so that's like Okay, of course, if you do minus one, let's start from minus one. Minus one is, this is the element from 1 to 9. So you're starting from in reverse order. So you're coming from the back. So what if you go, you can actually go 2 steps from the back. So 2 steps from the back is like, so you have your 9, then after 9, 1, 2, that's 7. This 8 will go. After 7, you have, after 7, you have 6, 5. So 5 follows. After 5, you have 4, 3. So 3 follows. After 3, you have 2, 1. So 1 follows. And that's what you get. 9, 7, 3, 1. Like that. So, okay, let me just do 3 steps from the back again. So the minus tells you it's from the back, right? That's important. So here you have 9. Of course, that's the starting point. So 1, 2, 3. That's 6. 1, 2, 3 is 6. And after 6, 1, 2, 3 again. 1, 2, 3. That is 3. Then after 3, 1, 2. So nothing more. So this just gives you 9, 6. Oh, sorry. I thought I had changed it to 3. 3 from the back. So it should be 9, 6, 3 actually. So that's 9, 6, 3. Okay, let me do 4. In fact, let me do 4. No problem. Let's do 4. So it goes 4 steps from the back. So 9, of course, is settled. Then 1, 2, 3, 4. That is 5. After 5, 1, 2, 3, 4. That is 1, and that is what you get. So, and you can go on and on. So thank you so much for, you can already see that 3 from the front, 3 from the back, 3 from the back is 963. It does not necessarily tally with 3 from the front like that. So not necessarily tallying like that. But it looks like 4 from the back tallies with 4 from the front. In fact, let's do 5 from the back too and see. This gets really interesting because you can see what you're doing firsthand. So from the back, that you have 9, of course. Then 1, 2, 3, 4, 5. So that's gonna be 4. Then after 4, yeah, so you don't have up to 5 again. So you just have 9, 4. So 5 from the front is 1, 6, but 5 from the back is 9, 4, as you can see. So that's what we have. So thank you so much for listening this far. It's been such a nice time talking about indexing and sliding NumPy arrays. So you want to try your hands on these things. So don't forget to download the notes. Just check the description box. You'll find the link to download all the notes I've made so far. And I'll keep putting the notes there so you can download and practice along because I believe in hands-on. So if you have not subscribed to this channel, be sure to do that. Hit the notification bell also so that you can always get alerted when a new video is released. Then don't forget to comment, like, and share. If you have any questions, feel free to comment so we can tackle that. Thanks for listening. See you in the next video.